20 years ago, a company in California built a new product. And it was a product that was entering a space that already had a number of competitors. But they did it 10 times better than any of the other competing products in that space. And then they went on to build technologies that have changed the way that we use the internet today. And in a lot of ways, have built technologies that are inescapable to our lives. That company, of course, was Google. And the web technologies that they've built over the last 20 years have really pushed the internet forward in a really big way. Sadly, load testing, by contrast, has not really kept pace. If you were load testing 20 years ago, chances are you were using LoadRunner, or you might have been looking for something really hot on the horizon like JMeter, which hit 1.0 pretty much 20 years ago today. Even 10 years ago, the only noticeable addition to this list that is still available today that is readily used is Selenium, and it's not even a load testing tool. Some of our customers use Selenium on Flood to do load testing, as it's a great open source product for basically interacting with the UI. But 5 years ago, a small team in France built a product called Gatling because they recognized that there was a huge opportunity to use modern technologies to build a load testing tool for the protocol level of load testing. And we at Flood decided to start a company around this, where we would build a platform for orchestrating load of open source tools and make it scale almost infinitely to be the best distributed load testing platform on the market. Interestingly, though, load testing hasn't really changed a lot over that time. It has not in any way kept pace with the level of technological advance that has come with the internet as a platform. Fundamentally, we're still doing load testing at the protocol level, as in simulating what happens over the wire, over the network. Fundamentally, as a practice, load testing is still the same thing as it was 20 years ago. It's putting demand on a system and measuring it for performance. And when most people think of performance, they think of response times. There are obviously other measurements that are really, really important when you're doing load testing as a practice, including transaction rate, concurrency, and network throughput. But response time is really what comes to people's minds, because response time and measuring that is the difference between you being faster or slower than your competitors. Now, being from Australia, I know a thing about response times. I know that it takes a human about 1.1 days to respond from Australia to Vienna. And we know that the internet, which roughly travels at the speed of light, more sort of, takes about 400 milliseconds to do the same trip across a few countries, 20 or so data centers, and a lot of undersea cable, 29,000 kilometers of it. But load testing is more than just measuring response times. Load testing is about giving you confidence in your performance, reliability, availability, and scalability of your application. So what does this really look like? We know the performance is essentially how fast does my application respond. The reliability aspect of this is how well does my application respond when certain things in the environment in which it's running in begin to change. For example, a database might go offline, or connectivity between certain services might become disrupted, or increased latency between certain services might influence the behavior of other components and cause cascading failures, as is what happened with Amazon on Prime Day earlier this year. This is very closely related to the availability of your service, because once all of these things fall apart, the availability aspect is what everyone notices. It doesn't matter if you're putting load on a system or people are interacting with it. Once the service becomes unavailable and starts throwing 500 errors, it affects everyone, and everyone knows it. Lastly is the scalability aspect of this, which is essentially forecasting how much it's going to cost you to run this load test, or how much it's going to cost you in production to run this many users. For example, if 10,000 users cost you N thousands of dollars in servers, What's 20,000 or 100,000 users going to cost you? And how do you forecast that if you're going large spiked events, for example, a product launch or a big sale day like Black Friday or Cyber Monday? A friend of mine once said that venture capitalists don't invest in dots. They invest in lines. They begin by taking conversations with a lot of different companies until they can create a picture of what that company is doing, and they can be confident that they're making the right decision and putting money into it. And the same is true of measuring performance. You can't measure performance by just taking a few tests here and there and hoping for the best, which sadly is still what a lot of people do with load testing. They put load testing at the end of their release cycle, and they think, well, Saturday's going to be quiet, we're going live on Monday, so we'll run a load test on Saturday, and then we'll have the results on Monday, and we'll hope for the best. Because the reality is that there's no way that they can react to those changes by next week. The reality is, load testing is like any sort of measurement, any sort of monitoring. It's connecting a lot of dots to give you a picture of how your application is going to perform in production. And now, obviously, the way to get all of these measurements is to be doing load testing continuously. Just like you know very well that you need to be testing continuously, testing every aspect of your release cycle, you can put load testing as early on as possible is going to make things a lot easier for you. So as soon as you have a system that is accessible to the internet, you can begin to put load on that. And things are a lot easier when things are simple. And that's always the case when projects start. The complexity of an application only grows as it goes on. Likewise with your testing. Another fundamental component of load testing and doing it properly is knowing which tools to use. You're probably going to hear over the course of the next 2 days, the protocol level testing is dead. It's kind of like the zombie apocalypse. And in my opinion, that's probably fairly true. However, it still has a huge role to play in doing load testing. But it's about knowing where to start. So there is essentially 2 layers to load testing. The first layer is the browser level, which is interacting with the application as a real user and creating load by simulating the users completing transactions at scale, essentially scaling horizontally to the number of users that you want to run. The second aspect, which I think comes into the picture a lot later on, which is using the protocol level tools to tune certain services which you identify bottlenecks in once you're doing your browser level load testing. So this might be your API layer, databases, certain internal services, microservices, testing how different caching layers behave and so forth. But the complexity of this is a lot greater than just interacting with the application at the UI layer. And lastly, the third component to this is analyzing the results. And this, I think, has been the biggest component that gets in the way of people doing load testing successfully, because understanding the results takes a lot of time and effort, and there's a lot of nuance to the types of curves that you can get out of different measurements, and they communicate different behaviors which are going on in your system. And I think this can be, in some ways, very intimidating for people when they first start out, which is something that we're working very hard at Flood to solve. So, 3 ideas: testing continuously, testing load continuously, I should say, analyzing results, and using the right tool for the job. I'm going to switch gears for a minute. Did anyone here catch the India Premier League final? One guy. All right. It was an absolutely magical return by the Chennai Super Kings. So for those who don't know, the IPL is the largest live stream sports event in the world. This year was the 2nd largest live stream they've ever done, and they spent months preparing for this to go live. And using Flood, they were able to scale up their load scenarios running Gatling tool to simulate 6.1 million concurrent users for a period of 8 hours to simulate an entire gameplay, including all of the events that went on through that. But that was only scratching the surface of what they were testing, because underneath all of that, They had spent months architecting their video encoding to ensure that it was low latency, their load balancer so that it could handle dropouts and services becoming unavailable without impacting their customers, and ensuring they deliver the right stream to the right device, whether it's a customer using a mobile service or desktop or streaming it to their tablet or to their smart TV. And a lot of these things are really fighting against you when you're doing live streaming. It's an incredibly difficult task to get right because when you talk about low latency and high quality, those things are kind of opposing because you can deliver low latency with a really poor quality picture, or you can deliver high latency and spend ages encoding the best quality stream, especially when you're encoding different versions of that and sending out to different customers, and then doing that at scale with 6.1 million viewers. So the end result of this, they did 4.8 million live streams during the final, which was at the very, very peak of that game. They simulated 6.1 million users on our platform, which generated 150 gigabits per second of traffic. Which, to put that in perspective, that would knock most websites off the internet if it was a denial of service attack. Fair to say, we might have burnt a small hole in the ozone layer that day while helping 5 million viewers enjoy the game that they love. Sorry, guys. So, using the right tool for the job is really, really important. As you've seen, Gatling tool and JMeter are very, very similar in their functionality, and it's not until you get to huge scale that you start to notice the certain characteristics of those tools that have a big impact. But I believe the future in load testing is really in browser-level testing, because this borrows a lot of concepts that we've taken and lessons that we've learned in building modern web applications over the last 10, 20 years, in that we now work at high levels of abstraction to what we used to do. So back in the late 90s and so forth, it was still very, very common that you'd be building enterprise applications in languages like C or other mainframe languages. The difference that's happened since then is that we've realized that a lot of that complexity can be buried within the framework. So now we work at very high levels and we describe our applications at very high levels. And the same is finally true of load testing and testing in general. So we know this is true within Tosca with our model-based functional testing. And the same is also true with load testing in that we can now use browsers to abstract away what's actually going on over the network and within our application, and not needing to have somebody who's an expert on every single detail to know how to craft a realistic load test. So I'm going to introduce you to a new tool called Flutter Element. And I'm very, very excited about this because today we're announcing this has hit 1.0. And to share a little bit of a story with you about how this kind of came to be, about a year ago, we had a lot of requests coming from our customers who were saying that load testing is really, really hard to get started with. I don't know what I'm testing realistically. And there was a big disconnect from those who were doing it properly and those who just wanted to hit a single URL. And there's all this gap in the middle we had to try and fill without saying, well, you've got to go do this course on JMeter and all these things that, when you just want to get results, it's just not something you have time to do. So the idea came to me that we could use a new automation technology that was a lot more efficient than something like Selenium WebDriver to drive a web browser at huge scale and build a language on top of that that was familiar to everyone who had done functional testing, at least from a scripted perspective before. So we've basically taken two of the best breed technologies. We've taken a familiar scripting language, which is Selenium, and we've combined that with a very, very high-performance browser automation engine, which is Puppeteer, which drives Google Chrome at huge scale on Flood. So we're essentially launching hundreds, if not thousands, or tens of thousands of instances of Chrome interacting with the UI and reporting the results back like a traditional load test. But the story doesn't stop there, because this opens up an entire new world of possibility when we're talking about what measurements we actually care about and we're measuring the actual user experience. So, because it's a browser, people are interacting with it. Traditionally, they'd be waiting for a page to load, and that is dependent upon things like your JavaScript loading and your images and your style sheets and all these things that depend on external servers, which can all become constrained at scale. So the possibilities here are really, really huge from a load testing standpoint because we no longer just have the picture of what's going on the server. We've now got the complete picture of what's going on from the client. And once you add server-side metrics to that, we can see what's going on the server as well. So while you're running a load test, you know exactly what's going on within your performance platform. And lastly, as I mentioned, it's open source. So Flood, from the very, very beginning, has been about open source. We built a platform for running open source load testing tools from the very, very first day. So I'm very, very excited to say that we're finally giving back to the open source community by building our own contribution to the load testing community with Flutter Element. And you can try this out today. It's on GitHub, and it's also at element.flood.io. So as a little bit of a recap, measure performance because you don't want to be slower than your competitors. There was a famous paper about 5 or 6 years ago that said that for every second of response time, Amazon would lose 1% of their revenue by people just abandoning the checkout process and so forth. So everyone cares about performance. Reliability, everyone's impacted by reliability. No one likes to see a 500 error. There's so many of them that the entire category of 500 errors literally means your application is unusable. And availability, is it 2 nines, 3 nines, 4 nines uptime? That doesn't leave much error for things going wrong. And how much does it cost to scale? And of course, you can tell I love this slide, but you've got to be load testing continuously. And this is all about what we're trying to do with Flood. So Flood has very tight integrations with Qtest from QA Symphony, which we've merged with earlier this year, as well as with GitHub, which we're about to launch, which is going to complete the DevOps continuous testing lifecycle. So use the right tool for the job, analyze the results, and test continuously, and that will give you the complete load testing story. So if I was going to make 3 bets for where load testing is going to go in the next 20 years, I think there are essentially 3 trends that I would be looking for. I certainly hope that Flood Element gets us there in 20 years, but even if Flood Element isn't the browser load testing tool of choice in 20 years' time, I can categorically say that browser-level testing and working at that level for load testing is going to be the big change that we see, because it naturally will allow us to test modern web applications very, very easily as the technologies underneath change. The second area is essentially reducing the complexity of load testing. We no longer want to be working with megabyte-sized XML files from JMeter and very complex, convoluted UIs. We want to be working with languages that describe our user behavior, whether that's a model-based interface from Tosca or a script-based interface from Flood Element, which I guess leaves the unpopular opinion in the room of scripting. I know Tricentis is the no scripting company. Puts me in an awkward spot to say this, but I think that scripting is inescapable in load testing to a certain degree. Thankfully, we're able to get most of the way there with Tosca Flood today, but there is huge benefits to still be made using a simplified scripting language, which is Flood Element, and integrating that within your complete release cycle and committing that with the code that is under test. So if you'd like to learn more about load testing, there is a workshop tomorrow at 4 p.m. And I'll be walking through essentially how all of the different tools work. So we'll look at Flood Element. We'll look at Tosca Flood for doing API testing and cross-browser UI testing. And we'll be looking at the Qtest integration with Flood and how you can utilize that today. Now, I've been told we have time for 2 questions. Any questions? This guy here.
So is Flood Element like completely open source? You can just start using it as of today?
Absolutely. So the core of Flood Element is open source, so you can use, it has all of the complete automation layer inside of it, and the scripting interfaces and so forth, so you can download it, run it on your laptop today, and that'll allow you to build up the test plan and so forth. And then in order to distribute the load, you upload it to Flood, and you get access to our distributed grid infrastructure, which gives you that scale.
Nice. And another question would be like, how do you actually write the tests? Do you write them in Scala, or do you write them in a programming language?
That's a great question. I did actually forget to cover that. So Flutter Element uses TypeScript, which is a superset of JavaScript. So it's the most popular language in programming today, basically. It also gives you a lot of autocomplete and validates your script as you're writing it, so you don't know. You don't get shocks when you upload it to Flood and find out that it doesn't work. You find out immediately that it doesn't work. And it's got a very, very nice interface for working with. And some of our early testers have said that it's actually more pleasant to work with than Selenium is, which I think is a huge compliment to us.
The proportion of load for the load generators in comparison to older or just direct calls, how higher is the demand for load generators with Tosca load as an example?
I'm not sure I quite understand the question.
Yeah, when you automate for load testing, you got to send them to the load generators to create the load. How many virtual users or threads in comparison to traditional?
At the browser level, we get about 50 per node, which is, by comparison, on Selenium, you get 2 to 3. So it's scalable in that sense. It often depends on the application under test when you're doing it at the browser level. So some applications, like video streaming services, obviously are a lot more demanding than something like a simple static application. For something like SAP Fiori, for example, we get about 40 users. So I think that's still very, very scalable. And on Flood, you can easily launch 10,000 users, 20,000 users at a totally modest cost. Alrighty. Thank you all for coming along.